7.4 Properties of Special Parallelograms. Essential question: what are the properties of rectangles, rhombuses, and squares? I hope at this point you know that a rhombus is a parallelogram with 4 congruent sides, a rectangle is a parallelogram with 4 right angles, and a square is both a rhombus and a rectangle. So these three theorems can be written in a very short fashion. We can say rhombus, if and only if. Now this phrase if and only if can be condensed and write IFF. If and only if it has 4 congruent sides. So remember, this is a bicondition. You can go in either direction. Rectangle, if and only if 4 congruent angles. And square, if and only if 4 congruent sides and 4 congruent angles. Now this is the relationship between rhombuses, squares, rectangles, and parallelograms. Notice that if a figure is both a rhombus and a rectangle, we call it a square. All rhombuses are parallelograms. All squares are rhombuses, rectangles, and parallelograms. Let's go ahead and try a problem. We want to decide for this rhombus, Q, R, S, T, and it must be in this letter order. You can go clockwise or counterclockwise. We want to determine whether this statement is always or sometimes true. Now they want us to decide if angle Q is congruent to angle S, and the answer is always. And it's because a rhombus is a parallelogram. And if you have a parallelogram, then opposite angles are congruent. Angle Q and angle R, are those going to be congruent? And the answer is sometimes. And that's because the rhombus must be a square. Once it's a square, then we know all the angles are congruent. Classify the special quad. Well, I know that it's a parallelogram, and that's because if opposite sides congruent, then it's a parallelogram. It's also a rhombus because if you have 4 congruent sides, then it's a rhombus. So if we're going to classify this, since we have 2 answers, we want to always choose the most specific answer, and so we'll say it's a rhombus. Here are some interesting characteristics about a rhombus. One is that the diagonals are perpendicular, and another one is that diagonals bisect opposite angles, so they cut these angles in half. Let's take a look at a proof for this first one. I'm going to look at this triangle, the red triangle, and I'm going to look at the green triangle. Now I know that this is a rhombus, so that therefore all the sides are the same. So AB will be congruent to BC, and that'll be a side. I also have AE congruent to EC right here, that's a side, and that's because diagonals are bisecting each other. Since it's a rhombus, it's also a parallelogram. We also have the reflexive property, which is a side as well. So these triangles are congruent by SSS. Now when the triangles are congruent, then these 2 angles, which I'll call 1 and 2 instead of the 3 letters here, angle 1 and angle 2 are congruent by CPCTC. But they're also supplementary because they're a linear pair, which means angle 1 plus angle 2 have to equal to 180, and they're both exactly the same. So we know that 2 times the measure of angle 1 is equal to 180, therefore the measure of angle 1 is equal to 90. Equally 90 means that these lines are perpendicular. Okay, your turn. And here are the answers. Take a look at what I've written. Stop the screencast if you need to look at it a little bit more. All right, we want to find the measures of these numbered angles, and I've listed everything I know about a rhombus. I know that it's a parallelogram. I know that it has 4 congruent sides. I know the diagonals are perpendicular and the diagonals bisect opposite angles. So I know right away that the measure of angle 1 is equal to 90, and that's because of this theorem. I also know that the measure of angle 2 is equal to 61, and that's because if you have a parallelogram, then the lines, then opposite sides are parallel. So I know these are parallel, therefore 61 and 61 are here. I also know that measure of angle 2 is equal to the measure of angle 3, and that comes from this theorem right here, bisecting. So the measure of angle 3 is equal to 61. Now to figure out angle 4, I know that these 3 angles have to add up to 180. I know this one is 90. I know this one is 61 degrees. So the measure of angle 4 will equal 29 degrees. All right, your turn. Here are the answers. Stop the screencast if you need to take a look. Next theorem, rectangle diagonals theorem. And it says that if you have a rectangle, then the diagonals are congruent. Now, these little tick marks right here are saying the same thing. This little tick mark here says this half is congruent to this half. This half is congruent to this half. But these two parts right here are the same as these two parts added up together. So it does say that these diagonals are congruent. This is the symbolism we use here. All right, let's see if we can use this in this situation. We're doing building a frame for a window, and the opening must be a rectangle. So they measure it, and they find that these are the measurements. Can we assume that it is a rectangle? And the answer is no. All right, the best we can say is if opposite sides are congruent, then it's a parallelogram. The best we can say that is that it's a parallelogram. Okay, so part B is we're going to take some more measurements. We're going to find this measurement, which is 54.8, and this measurement right here, which is 55.3. So these are diagonals, and the diagonals are not congruent. So what can we conclude about the shape? We can say that it is not a rectangle, because if it's a parallelogram with diagonals congruent, then we can say it's a rectangle. And unfortunately, the diagonals are not congruent. So the frame is a parallelogram. That's the best we can say about this. Okay, we have a rectangle and we want to find the lengths of the diagonals. So these are the diagonals, QS and RT, and this is a rectangle. So I know if I have a rectangle, then the diagonals are congruent. So I'm just going to set them equal to each other. And I get 3x is equal to 42, x is equal to 114. And then I have to put 14 in here. So 2x plus 11 is equal to 28 plus 11, which is 39. So they're each diagonal will be 39. All right, we want to decide if this parallelogram is a rectangle, rhombus, or square, and I'm going to do it by looking at diagonals. So I'm going to look at diagonal AC and find its slope. So the slope of this is going to be 6 take away 0 all over negative 2 take away 4, which is 6 over negative 6, negative 1. Okay, DB, I want to find its slope. So that's going to be 8 take away negative 2 all over 6 take away negative 4. That's going to be 10 over 10, which is 1. Now, these slopes tell me that segment AC is perpendicular to DB because the slopes, because they're opposite reciprocals. All right, so now I know for sure that it's a rhombus. I know it's a parallelogram, and because the diagonals are perpendicular, I know it's a rhombus. Let's take a look at the distance. Now, visually, you can see the distances are not the same. So I'll go ahead and figure them out, but visually we can see that it's not going to be. So it's going to be, it looks like it's 3 squared plus 3 squared, which is root 18, and dB is root, let's see, 1, 2, 3, 4, 5, 5 squared, 1, 2, 3, 4, 5 plus 5 squared, and that's root 50. Now we can see that these are not congruent to each other, so it cannot be a rectangle, and if it's not a rectangle, certainly it can't be a square. So if you have a parallelogram with diagonals perpendicular, then you can say it's a rhombus. Okay, your turn. Stop the screencast and see what you can do. And here's the answer. Again, I looked at diagonals. I found that the diagonals were perpendicular. I also found that diagonals were congruent, which made it a rectangle. And since it's a rectangle rhombus, it's also a square.